subdirectories. And so my subdirectories are a.
How would that,
So
we're talking about the database,
so there's
Browser no work. Okay, check.
Can't make your computer work, but darn it, I can program a computer.
That's right. Now I got it.
and then isolation
So we just like 10 seconds to start.
like is this direct? Is it direct? Then we're going to get like you're gonna have an iterator over every.
what if not all?
Well, so it's building, it's getting, it's grabbing every small image, and that's how we're gonna define it. So, but then it works on getting, this is also a directory that has a subdirectory, that has a subdirectory. It's like, is this a directory? No, okay, this is active. Is this a directory? No, this is active. This is a directory? Yes. Reversibly call myself. Is this a directory? No, that's also. So it just builds the entire data structure. Just naturally.
That's why we want to go with that.
So, work with the apps.
So, various things. The RTA, Art Kuduro, has office hours posted as 8 to 9 Tuesday mornings. Probably partly because it's 8 to 9, but partly maybe because people don't know about it. People haven't been showing up. Art's fantastic and a great resource, and I would encourage you, especially as homeworks are coming due and that sort of thing, to use that resource. If nobody's using it, I'm just gonna have it cancel them. There's no point in having it be there for an hour and empty leave. So, let me know what you guys want to do. Maybe the Slack's good enough for everybody and office hours aren't a necessary thing. I don't know. What else? What is it the homework due date? Like tomorrow. Yeah. So, I mean, we probably should take a few seconds and, if people have questions that the whole class might be interested in. I mean, I think we got most of it on the Slack. I would really encourage you to check out the Slack if you haven't yet. There's some notes on the homework there and some interesting questions and answers by people. So it's a useful resource.
I found something interesting on Say. I put it up in the Slack, but in the prompt it only asks you to go from 0 to 999,999,999,999. But two of the tests ask you to go to the command billion, so
Yep.
it will overflow.
That's one of the extensions.
Okay.
I would encourage everybody, and by encourage I'm more or less mean require, to go ahead and extend your thing to work all the way to, full U64 range. That's absolutely doable, and not that much more work once you've got a proper infrastructure in place. I don't need you to actually produce speech. In fact, please don't. It's fiddly and OS dependent, and I mean you can on your own, but don't submit that. And there was some other thing in there that I didn't care about anybody doing, but for the most part, do all the extension bits. They're mostly perfectly reasonable things. Oh, the ands. Don't do the ands because the tests don't have ands in them, so you have no way to test it. As the comment in there somewhere says, British usage often has ands in it. American usage usually doesn't. We don't say 1,000 and 199. Yeah, that's a good question. Anything else we need to talk about? Yeah, okay. So we're at a funny place in this course. Every time I've taught this course, we get to this funny place, and we're here today. The stuff we're fighting with right now is sort of what I'd call intermediate Rust stuff. I mean, we really finished the beginner Rust stuff not too long ago, and at this point, it's all this stuff that honestly takes years to really get super comfortable with, or at least took me years. I don't know, maybe I just don't know what everyone did that, but it takes a long time and a lot of practice to get super comfortable with. What that means is, you probably really want to, that was the other thing I meant to say today. If you're not caught up with the book, if you haven't been using the book, if you haven't been reading the book carefully, I'm going to exhort you one more time it's totally worth it in terms of learning Rust. You know, just plan to do a chapter a night for as many nights as it takes to get back to other classes, because it's really a good book, and it really covers a lot of these things in more detail than I can't in class, both because I just don't have time, and because, you know, you sort of want to interact. You want to sit there and program while you're doing it. You want to have play open or have something open and be actually typing code fragments in and seeing what they do. And we try to do some of that in class, but obviously the code fragments you choose to type in are going to be different from the code fragments I choose to type in. So really, especially for these chapters that are assigned for this week. Iterators and traits are one of the areas where if you watch the places where people ask Rust questions, a lot of the questions are there. So sorting that stuff out, iterators, traits, and closures, sorry. You know, sort of the topic that we covered partly yesterday and today is iterators. Before that we covered traits, and now we're going to try to cover closures. This is sort of the intermediate Rust body of knowledge, is how to do those things. So, it's kind of a sticky time. I'm thinking already about what the next homework's going to be, which will probably be the last homework. And thinking about what kinds of things I can give that will give you practice with these concepts, because these are not easy concepts. So we talked about iterators quite a bit yesterday. I don't remember how far we got through these slides. I'm going to sort of start through the slides again a little bit. We'll do it faster than we did last time for part of it, but I sort of feel like there's a lot here to talk about. The iterators are kind of a big deal in Rust. And so I want to make really sure that people are clear, because you use them all over the place. Once you get used to writing in this functional iterator-based style, you've got a thing going that, you know, sort of will get you more and more programming with iterators instead of programming with loops. We could have an interesting argument about whether loops or iterators are better style. Rust admits both. It's perfectly happy to have you write very C-looking code. It's perfectly happy to have you write very Haskell or at least SML-looking code. It doesn't really care. Even the tools don't care. Puppy won't whine at you beyond a certain point. But one of the advantages of the sort of combinator-based approach with iterators that a lot of people like to write Rust in is that it's harder to make mistakes. And since Rust is all about, if anything, not making mistakes, the advantage of an iterator is that it's harder to have off by one error to an iterator. It's harder to, you know, either iterate over the wrong bounds drastically because you screwed up, not just sort of iterate off the wrong bounds subtly because you sort of can't count. In particular, iterators over collections and that kind of stuff. So it's hard to miss the last element in an array or walk one past the end of an array because you don't iterate over the, over the indices of the array, you iterate over the stupid array most of the time. So having said all that, let's review a little bit. There's nothing magic about an iterator. An iterator is a trait, and it has an associated type called item, and it produces a sequence of option items on calls to its next method. So, you know, maybe we should just write the standard iterator for numbers. I guess we wrote an iterator for primes last time. Maybe that was too fancy. Let's just write the iterator for numbers. We need our own type because we want to implement on that type. I can't implement a trait from the standard library directly on a standard library type because that's against the rules. But I can do this. Let's make this, let's call this range. That's a better name. We'll make a start and an end. And then we'll change up our little thing here. So we need some way to make a new range. Start : U64.
N colon U64 gives us a range, and it's just gonna be the obvious range. You notice I'm using tuple structs a lot. It's a matter of taste, whether you do that, but it's really convenient in situations where you just don't care that much what you're gonna call things. I could name those start and end and pass them that way. It's a matter of taste, I don't know. It might be better here to give them names, but we didn't. And let's implement an iterator for ranges. Type item is U64. We're pinning our numbers to U64s here, which is kind of gross, but you know, you can imagine making some trait for that too, where you sort of, you know, have some numeric trait that sort of that you use instead of U64 for your type, and you can do iterators for all different numeric types. So let's, so this is the simplest possible thing here, I think. So what is our next function gonna do here? Notice that because we use self, we don't actually have to change any of the sides of this. This is the nice thing about using self instead of the explicit type. So how is our next function going to work? We have this thing that we want to iterate over a range, which means each time next should return some next value until it runs out of values, and then it should return none, right? Everybody get that part? That all cool? So what should I write here? Somebody help me out. Well, one thing to think about when you're thinking about iterators is state. So that struct range that we had is sort of the structure that holds the state of our iterator. And the gross part of Rust iterators, which I don't like very much, is that you have to manage all that state explicitly, right? You have to have enough information in that struct so that you can always tell what number to return next. Do we have enough information in that struct to tell what number we should return next? I see a no. I think the answer is yes, but I understand where the no's coming from, so it's not a bad answer. Why no?
There's nothing counting where we are now.
There's no index. So the sort of natural thing to do, the sort of automatic thing to do, which is probably a thing you could do, would be to add a third field to the iterator, right? Which says which number we're returning right now, right? And that's perfectly reasonable. How can I get away without it?
Can you use the value you're returning?
I mean, you still have to mutate the structure so you know what to return next time, right? Iterators are all about what am I going to return next time as well as what am I returning this time, right? So where can I store information about what to return next time? No, it probably needs to be in the struct. I've only got two numbers in the struct. Could I somehow reuse one of them to hold the state? Well, I can't change the end, because if I change the end, I won't know when to stop properly. That only leaves one thing I can change. What can I change? Right? Can I do that? Can I actually have the start? Can I actually change the start value on the range as I iterate through the numbers? Oh. And this is part of why I wanted to do it again slowly with a simpler example, is that sort of this iterator engineering thing is all about sort of what state do I need to store, how am I going to store it, right? And the frustrating part is sort of the invariant stuff, like the endpoint is part of the struct. The variant stuff, like the start, is also part of the struct. And so, you know, the internal states of iterators can get really complicated. And this is the worst thing about Rust iterators, is that implementing them is kind of a pain, because you end up building all these gross structs with a whole bunch of notes about what's going on in them, so the iterator can do its job. So maybe we're closer now, understanding what's going on. And by the way, I can get rid of that is prime implementation up there. I don't think we'll be wanting that anymore. So, having just had the discussion we just had, what do I want to write here?
what value am I going to return next? The start, right? And when am I going to return? When am I going to return none?
At the end.
Well, what does at the end mean? How do I test if I'm at the end?
When start equals end.
When start is equal to end, yay! And we'll be safe defensive programmers. So the first thing I gotta decide is whether I'm returning none or not, right? And I'm gonna write this first in the C-ish way. And then we'll re-rustify it a little bit later. But now, so I've already decided that I don't have to return none here. So what are my two things I have to do? I have to return the thing I'm going to return this time, which everybody told me is start. What else do I have to do?
You have to increment start.
Oh, and by the way, you're already missing bugs in my code, so you've got to help me out here. This is not start, it's called self.0 because we didn't give names to these things. And this is self.1. And at that point, I look at that and I think, you know what, we're going to go back and change this into a struct with named fields because that's gross.
Remind me why self.0 and self.1 is what it's named.
Zero, self is because we're talking about the range struct, which is passed in as self. And the dot zero is because we're talking about the first field in that tuple struct. And we count like computer scientists instead of people. And so we're going to do this instead, because otherwise we're going to get really frustrated really fast. Actually, I knew that was a mistake when I typed it in. Here's a good rule of programming that nobody ever tells you. Listen to your inner voice, listen to your subconscious. When as you're typing something, you're thinking, you know, this might be a bad idea. That's as loud as your subconscious gets. It's screaming at you. It's screaming, this is a bad idea. You should stop now, right? And rather than just plowing on with a bad idea, just stop. Just think about what you're doing and stop for a minute. It's trying to prod you out of flow state as much as anything, so get the heck out. Now we have to fix this, of course. This is going to be a very difficult fix. Oh man, I don't know. I have to change both these braces. That's terrible. All right. So now we're back to where we were, and so now we can say self.start is greater than or equal to self.end, which is, I think, easier to read. And we could even get them in the right order. All right. So we have to do two things. We have to increment the start, and we have to return the current start. Well, wait a minute. Those have to be done in the correct order, right? Do I want to return the current start or the next start? Well, I probably want to return the current start, right? This is a common iterator thing. So what am I going to do? Some start. I have to return some start. That is true. But what am I going to do? How do I, so if I just write this, which is the obvious thing to write, is that a bug?
Yes.
Yeah, because I missed the first element of the iterator. So that's no good. So what do I want to do here?
You probably want a bag to hold it in, like let start or let next equal start.
Oh! You want me to write, and by the way, self.start. Nobody's catching any of my mistakes today. You got to pay attention. You want me to write this is what you're trying to tell me. Yeah?
Will it work?
Well, will it work? I'm not going to tell you. I mean, I might be wrong. It's the worst thing an instructor can be in front of a class is wrong. Not. What? So, can I increment self.start? What gives me the right to do that? Yeah. It's not mutable? What is self? Where is it declared? At the top of next. Oh yeah, we passed self by mute pointer. And now you know why iterators have to have mutable state, right? It's because that's the whole point of an iterator, is to sort of update its notes as it goes about what thing it's supposed to return next. So that looks okay. I kind of feel like I don't see anything super obviously wrong. Anybody else see anything super obviously wrong?
Is the semicolon on line 4?
Line 4. Yes! Yes, it is. And I don't remember if the compiler will actually whine about it or not, but it's definitely unnecessary and kind of gross. It's left over from when the struct was a tuple struct. Thank you. Good catch.
Import iterator for capital U64.
Oh, is that capitalized? Yep, that's a bug. So look what happens here, right? And I know you're all way better programmers than I am and never do this. But, you know, anytime I type something in, being fallible like I am, I'm gonna make terrible mistakes, right? Not terrible mistakes, dumb little mistakes, right? Read your code before you hit return on the compiler. It's a fantastic plan for improving your code. I already have made a mental note that this code is gross, and I have a plan for how to fix it. Probably, I should make a physical note in here that looks like this. XXX restructure the ifs. Because I know I want to restructure the ifs in a minute, but here we are. And now let's fix our main program. I in range 1 to 10.
Does an iterator have to consume the object for the fuse function?
It does kind of. It doesn't have to consume it, right? It's passed by mutable reference,
Right.
but it is going to get changed, right?
Right.